Hello everyone, the content of this course we will learn is the effect of gas on the weld metal. The main contents include 1. The effect of nitrogen on metals and its control. 2. The effect of hydrogen on metals and its control. 3. The effect of oxygen on metals and its control. During the welding process, a large amount of gas is filled in the welding area. And these gases continuously undergo metallurgical reactions with the molten metal and molten pool metal, thereby affecting the composition and performance of the weld metal. Therefore, it is necessary to first understand the source, composition and quantity of the gas in the welding zone before further research on their interaction with the molten metal. The gas in the welding zone comes from the welding material, the gas medium around the heat source, the impurities on the surface of the welding wire and the base metal, and the gas generated by the high temperature evaporation. The first part, the effect of nitrogen on metal. The nitrogen in the gas phase mainly comes from the air around the welding area. Even if welding is performed under better protection conditions, a small amount of nitrogen still invades the welding area and interacts with the molten metal. The dissolution of nitrogen in metal is generally considered to have the following three forms. The first one, melting in atomic form. The nitrogen molecules in the welding zone are first adsorbed by the metal surface and decomposed into nitrogen atoms. And then the nitrogen atoms pass through the metal surface layer to the metal dissolves inside. The second is to dissolve in the form of ions. Nitrogen atoms are decomposed into nitrogen ions by the collision of high-speed electrons, which are neutralized with electrons on the surface of the cathode and dissolved into the metal. The third, dissolve in the form of NO. Nitrogen is a harmful element in carbon steel welds, which has the following effects on the welding quality. 1. Promotes porosity in the weld. Nitrogen has a certain solubility in high-temperature liquid metal. During solidification, the solubility of nitrogen suddenly decreases, and the supersaturated nitrogen overflows out of the molten pool in the form of bubbles. When the crystallization rate of the weld metal is greater than its overflow rate, nitrogen is in before the weld crystallizes, it is too late to overflow, and it remains in the weld metal to form pores. 2. Reduce the mechanical properties of the weld metal. When the nitrogen content in the weld exceeds the solubility, a part of the nitrogen will exist in the solid solution in the form of supersaturation. The other part of the nitrogen will be precipitated in the form of acicular nitride Fe4N. The strength and hardness of the weld metal increase, while the toughness and plasticity decrease. 3. Aging embrittlement. The effect of nitrogen on welding quality. During welding, the cooling rate is large, and nitrogen has no time to precipitate with the decrease of temperature. The supersaturated nitrogen in the weld metal is in an unstable state. After a period of time, the supersaturated nitrogen will precipitate as needle-like Fe4N, causing embrittlement of the weld metal. In order to eliminate the harmful effect of nitrogen, the measures to control the nitrogen content of the weld are generally divided into strengthening the protection of the welding zone, adjusting the welding process parameters, and using alloying elements to control the nitrogen content of the welding seam. Commonly used protection methods in production include gas protection, slag protection, gas slag combined protection and other measures. Select reasonable welding parameters. Increasing the arc voltage will cause the protection effect to deteriorate. The interaction time between nitrogen and droplets will increase, and the nitrogen content will increase. In order to reduce the nitrogen content in the weld metal, try to use short arc welding. Excessive welding current will cause the metal to evaporate strongly, the partial pressure of nitrogen will drop, and the nitrogen content in the weld will gradually decrease. When the diameter of the welding wire is increased, the droplet becomes thicker, and the nitrogen content of the weld decreases. Use alloying elements to control the amount of nitrogen in the welding seam. 1. Increase the carbon content in the welding wire or coating. 2. Titanium. Aluminum and rare earth elements have greater affinity for nitrogen and can form stable nitrides. The second part, the effect of hydrogen on metal. During welding, hydrogen mainly comes from the moisture in the electrode coating, flux, and welding wire flux core, organic matter in the coating, impurities on the surface of the weldment and welding wire, and air, moisture, etc. In gas-shielded welding, it also protects the moisture in the other. Different welding methods have different ways of dissolving hydrogen into metals. 1. During gas-shielded welding, hydrogen is dissolved into the metal in the form of atoms or protons through the interface between the gas phase and the liquid metal. 2. During electroslag welding, hydrogen is dissolved into the metal through the slag layer. 3. During manual arc welding and submerged arc welding, the dissolution of hydrogen is the result of the above two ways. In the steel weld metal, most of the hydrogen exists in the form of hydrogen atoms, positive hydrogen ions, or negative hydrogen ions. Hydrogen has a strong diffusivity, and hydrogen ions can diffuse in solid metals even at room temperature. The harmful effects of hydrogen can be divided into two types. One is transient phenomenon, including hydrogen embrittlement and white spot. The other is permanent phenomenon, such as pores, cracks, etc. The characteristic of hydrogen embrittlement is that the plasticity of the metal is significantly reduced, but the impact on the strength is small. Hydrogen embrittlement often causes the overall damage of the structure, which has a great impact. When the hydrogen content in the weld of carbon steel or low alloy steel is too high, a silver-white circular local brittle fracture point often appears on the section of the tensile or bending specimen, which is called white point. The white spot greatly reduces the plasticity of the weld. The higher the hydrogen content in the weld, the greater the likelihood of white spots. Formation of pores. The air bubbles do not escape from the weld before the metal solidifies, and pores will be formed. Cold cracks. Welding cracks that occur when the welded joint is cooled to a lower temperature, below MIS temperature for steel, are called cold cracks. Welding cold cracks are the most serious welding defects. Measures to control hydrogen. First, limit the hydrogen content in the welding material. In production, in order to reduce the moisture in the welding material, the welding rod and flux must be dried before use, which is also the most effective method in production. Remove impurities on the surface of welding wire and weldment. Carry out metallurgical treatment. Reduce the solubility of hydrogen in liquid metal through the metallurgical effect of electrode coating and flux. Dehydrogenation treatment is often required for weldments that are prone to cold cracks. The third part, the effect of oxygen on metal. Oxygen mainly comes from oxidizing gas, oxidizing slag in the arc, and rust, moisture, oxides, etc. on the surface of the weldment and welding wire during welding. Oxygen will be decomposed into atoms under the high temperature of the arc, and oxygen is dissolved in liquid iron in the form of atomic oxygen and FeO. Due to the oxidation of the weld metal by gas and slag, the oxygen content of the weld metal is higher than that of the base metal and welding wire. Whether it is in the form of solid solution or in the form of oxide slag inclusions, performance is adversely affected. The influence of oxygen on the quality of the weld metal, the strength, plasticity and toughness of the weld are significantly reduced. Form stomata. In the molten pool stage, dissolved oxygen undergoes a metallurgical reaction with carbon. and the reaction product is metal-insoluble CO. If the CO bubbles have no time to escape during the solidification of the molten pool, Colorado pores will be formed. Oxygen burns out beneficial alloying elements, thereby deteriorating the properties of the weld metal. Splash formation. The metallurgical reaction of oxygen and carbon in the molten droplets generates CO and expands when heated, causing the molten droplets to explode, forming splashes, and destroying the stability of the welding process. Students, this is the end of this lesson. Thank you for watching.